Hello, this is Stephen Mcnutt from Densemode.com. In this video, we're going to do a quick discussion of the main configuration components of IKEv2, also known by another name of FlexVPN, which is what Cisco calls it. So this is just going to be real quick and basic. I'm not going to get super deep into the technical details. It's more of just a high level so that when we go and look at the configuration pieces in the router, you have like a basic concept of how they relate together. So there's the way IKEv2 works is there's actually two main sections or two main things that happen when the everything's being negotiated for a VPN tunnel to come up. And the first thing that we're concerned about is something called a NIT. So NIT is the very first thing that happens. If you're familiar with IKEv1, this is called in IKEv1. This is called phase 1, but in Flex or IKEv2, we call this a NIT. And like I said, we'll stay out of the technical discussions, but just know, just in your mind, it's okay to equate a NIT with phase 1 if you're familiar with IKEv1. And then phase 2, what is called auth. Now these don't completely overlap, but just for the sake of keeping things straight, the second portion of IKEv2 coming up is called auth. And then I'm going to draw a third box down here for later. And this box down here actually represents our interface. Okay, so that's our big wide ass interface, right? So within a NIT is kind of its own separate thing. It's not really related to auth. A NIT has two pieces. A NIT has what's called a proposal. This would have been called, and this is where the terminology gets super confusing, this would have been called a policy in IKEv1, but we call it a proposal. And this is just where we set the crypto suites for the initial negotiation when we're setting up the tunnel. So we're saying we're going to use these protocols, and we're just going to send this is our proposal. So we have we can create a set of proposals, and then we have a set of policies, and then these policies define where we're going to use these proposals, like what VRS we're going to use them for and stuff like that. And then so that's like the first part, and then the second part in auth, there's the main component where most of the action happens is the IKEv2 profile. There's there's a whole bunch of other stuff you'll do that tends to roll up into this profile. And then there's the another thing that you'll always see in there is the Ipsec Transform Set, which falls under this because this is negotiated. The parameters for these parameters are sent as part of the negotiation and auth. And then we have the Ipsec Profile. The Ipsec Profile is where we tell our router, okay, this is the IKEv2 profile, and this is the IKEv2 Ipsec Transform Set we want to define under this profile. And then this profile is used down here. So this profile is just like a container. So I'll get to that in a second. And then there's an optional component, which is the keyring. So if you're using a lot of keys, you can do a keyring. So if you have like a profile with and you have a bunch of peers and stuff, you would use a keyring. So that's an optional component. You don't have to use it, but it's there for you if you want it. And then down here, the interface is where the Ipsec profile actually kicks in. That's what its reason for existence is. So you would do like tunnel protection, Ipsec profile, foo, right? So that's just telling the router that we want to use the Ipsec profile. We want to apply it to this interface. So that's all that the Ipsec profile really exists for. So having done that, we're going to go ahead and do a basic configuration. We're going to use something called smart defaults, where everything has been predefined except for auth. The only thing that hasn't been defined is there's a few settings in the IKEv2 profile that we have to specify. There's just a couple little things, and the tunnel will magically come up. It's really cool. So let me show you that. So first, it probably makes sense to take a look at the topology. So within this, our just kind of this lab topology I just keep reusing for stuff. We're going to look at R2, this guy here. Let's pick a different thing. There we go. Like that. We're going to do R2 and R3. So we're going to make a VPN tunnel between these two guys, and we're going to use smart defaults to do it. So let's hop back over here. Okay, so take a look, and okay, so those are our IP addresses. So that's the internet facing side of this guy. So he's .2, and we'll take a look at the show IP interface brief. And then he's .18 and show IP route. Okay, that's good. So let's actually just 0.13.2. Okay, we have reachability, so we're cool. So let's go ahead and get started. Let's look at the let's not look at defaults. Let's just build it. We'll look at the defaults later. So we're going to do crypto IKEv2 profile default. You have to call it default if we're going to use the smart defaults. And here we get some instructions. Isn't that nice? So we'll say authentication. We'll say authentication local key pre-share key Cisco. And we'll do the same thing for the remote pre-share Cisco. Match identity, what was it, .18. Okay. You can also match identity any. Let's just do it that way. We're in a lab. I don't care. Match identity, remote, any. Looks good. Okay, so then we'll do interface. And we'll do interface tunnel 0, tunnel source, and we'll just source it off of this IP address here. And then we'll do tunnel destination, which I think was 18 if I recall correctly. Double check that. Yep, 18. And then we'll say tunnel protection, Ipsec Profile default. Let's pick an IP address, 192.168. Show IP interface brief. Okay, so there we go. Show run section crypto interface tunnel 0. Show run. Okay. So let's grab all this. Pop it in a notepad. And we're going to swap these around. 2. Change this to 2. Get rid of this stuff. Should be it. That looks good. All right, so let's just drop that onto our other router. IP interface brief. And ping 192.1.1. And it's working. How about that? How cool is that? So that took us, what, I don't know, 3 minutes. It would have been less if I hadn't got stuck with making a bunch of typos. So let's actually look at what happened. If we take a look and do like a show crypto IKEv2 SA. So here's our IKEv2 Security Association. This is all just defaults that have been predefined. And let's do show crypto IPsec SA. And there's everything's good there. So here's our system created crypto map. So we can see this is a GRE tunnel. So we could easily change that if we wanted. We could eliminate that with a simple command. It wouldn't really make any difference, but if we wanted to, we could. And we can see there's our packets have been encapsulated and decapsulated. So that was ridiculously easy, right? So let's take a quick look at what those smart defaults look like. Show run all section crypto IPsec IKEv2 proposal. So let's look at the proposal. So this is the default proposal. So if I remove this show run all, you'll see it's not there. So it's hidden. If you show run all, you can see it. So there's our default proposal. And then here's our default profile policy. Let's look at the policy. Okay. So these are the two things that are init. So this is like the init, the first part of the negotiation. So it was kind of cool. So you can give these different names, and so you can see not only can you set what proposal you want to use of the policy, but this is really important, which is you can tie it to specific VRF, and we'll have a lot of fun with that later on in some further videos. So let's take a look at the default profile. And here we can see that there were some other things that we didn't, that it's pretty, look at that. It's a good thing I copy pasted, because I had some white space, and I don't see any white. I think it's just because when you do the all, it's got all the potential warnings you could have. So those are the defaults, and as you can see, there's like a bare minimum. We got the instructions on what the minimums were. We had to define local and remote authentication, and then how we were going to match our peers. And that's one thing you would notice that would be different with IKEv2 between IKEv1 and IKEv2 is IKEv1, if the authentication is got to be the same on both sides, whereas you can actually have completely different authentication methods for one side and the other. It's asymmetric, which is really kind of cool. And then let's see, show run all section IPsec profile. Forgot to call a section there. And if we do that, notice we have should be in here. There we go. Set IKEv2 profile default. So the smart default for the IPsec profile, it's got the IKEv2 profile default embedded in it. And then if we do the transform set, which should be, see where it should be calling that as well. Should be, I don't see it in there. That's interesting. There's our default transform set. So that's what made it work. So there you go. Quick and easy. We got a site-to-site VPN up with how many commands was that? It was like not counting the interface commands, which you already would have. It was 5 commands. So it's 5 commands to turn up a tunnel. That's not bad. So you could take these 5 lines and just copy paste them into 2 routers, and bam, you're up. That's it. So there you go. I hope you enjoyed this. Like, share, subscribe. Visit the site densemode.com for more blog articles and cheat sheets and other fun stuff. Have a good one.